Are you good now, Chris?
Yep.
Okay, we're live, guys. So, um, I'm gonna do a quick screen share so we can all see. Well, I guess I don't need to. We all know we're working on problem number one of the group quiz for now. Get that out of the way, and then we can jump into the extension problems.
Sounds good. Who wants to pray this time?
I can.
Okay.
Dear kind and gracious Heavenly Father, we're so very thankful for this day, and we're thankful we could all find a time to meet together, and we're thankful that we could prepare for this exam that we have this week, and please bless us so we can have the Spirit to be with us, and that we can accomplish all that we need to, and work through our problems together, and help each other understand the content that we're learning. And I say it's in Jesus Christ.
Amen. So for the first problem, I can kind of share what my ideas was towards how to.
Okay, that's fine.
Sorry, not that. All right. Okay, if you guys can see that. So this is the S. So what I did, I subtracted the C to the other side to get AX squared plus BX. And since you kind of want to get an X squared plus something, so that you can get two like binomials to times each other, I divided by A. So A here, so you get X squared plus BX over A, and then A on this side. And so you got this little X squared plus BX divided by A. So what I think is, like, for example, if this was X squared plus 4, you would divide that by 2, right? And then it'd be it'd be 2, and then you square that, so you'd be adding 4 on both sides. So X plus 2 squared, all of it squared would be how completing the squared would work. So with this, you would have to divide this number, bx over a, divided by 2, and square that number, and then that number that you get, you would add to both sides. That's how I understood completing the square worked.
So, with the homework, I had a lot of problems with like figuring out how to like complete the square and stuff. So I looked at a lot of the examples that they did, and when it gives you a quadratic equation like this, what they say to do to find the x-intercepts is it's b over 2a, 2 times a, and then it gives you the x-intercept, and then to find the y-intercept, you have to plug x, whatever answer you get from x, back into the equation, and then it'll give you y.
Oh, cool.
So we just have y equals the ax squared plus the bx plus c, right? And then you're plugging in b over a for the x's.
b over 2a.
B over 2a plugged in for x's, right? That what you're saying?
Yeah, and so that, from what like it showed me on the homework, is that's how you find the x-intercept for it. And so then for to find the y-intercept, it's the function of b over 2a. So like kind of like that part. So like
Yeah.
f of b over 2a. And then that gives you the y-intercept.
So this would be the equation right there if you plug in the b over 2a. Is that what we're thinking?
Yes.
Okay, and then just kind of go from factor that out pretty much.
I think so, because like I was like really confused on it. So I looked at like, so you can ask for like an example on the problem, and every time that I
Mm-hmm.
would get the example, it would pulled this like equation up for me that would show you how to find the x-intercepts. So that's what I understood was for the x-intercepts, and then the y-intercept as well. But like I'm not sure if that's like the answer for it. I guess like x equals b over 2a. I think that's the answer because that should be.
That would make sense because
I think-
that's the generic way.
In the extension problems, when you like look at the answer key they have for theirs, there's like multiple x-intercepts for one of them. So that's what I'm a little confused about.
Oh yeah, I get what you're saying.
Yeah. So I'm not sure if it's like, because it's the same kind of problem, but it's like, and it doesn't it say in the group quiz list the x-intercepts like multiple?
It does say that.
Yeah.
Yes, I believe it does.
Were
Find
you-
the x-intercepts of the quadratic equation. Yep.
Yeah.
Were you guys pretty successful in finding, for the extension problem number 1, the x-intercept there?
No, that's what I was trying to do before we got on. It was just making my mind just go on hold. It's been.
So I can show you what I did. I got the answer. Where is it? Okay, so this is the function, right?
Yeah.
So I subtracted 8 to this side, so you get negative 8 equals 3x squared minus 4x. All right? You divide by 3 on, like, so you divide all this by 3, so you get 8 divided by 3. So don't look at the 4 over 9 right now. Negative 8 divided by 3 equals x squared minus 4x over 3. At that point, you divide the negative 4x divided by 3, you divide that by 2, and you get negative 2 divided by 3. And you square that, so you get plus 4 divided by 9, and you add that to both sides. So that's why that's on both sides. So when you do that, you get, well, this right here, to get that, well, that's wrong right here. Oh, yeah, that's right. You just find a common denominator with 9. So I times 3 there, so that's 9, and times 3 there, that's negative 24. So that's how I got that side, all right? And then since you get this right here, this factors to this, which is x minus 2 divided by 3 all squared. And you square both sides. And then on this side, because it's 4 minus 24, you get negative 20 over 9 equals x minus 2 over 3. Then over here, because you add the 2 over 3 to the other side, and then you square the bottom of the 9, so then that's 3. So that's how you get the answer of x equals plus 2 over 3 plus or minus the square root of negative 20. And then he just pulled out the negative. That's why he put I, because it's a square root and you can't have a negative under it, divided by 2. So that's how you get that answer. And then the other one is 0 because if you have a y at 8, then it has an x at 0 because that's where it has in the graph. Does that make sense?
Yeah.
Yeah.
I think it just gets more complicated because they have letters.
I know.
So what I understood, because I saw a lot of like YouTube videos and stuff, is that there's multiple ways to find the x-intercept or the root or whatever. So we could tackle it a lot of different ways and still find the right answer. So I don't know what you guys want to do for number 1 there.
So actually, what I was telling you, that equation that I showed you guys gives you the x-intercept, and then it'll give you the vertex of it. So for that equation with the x equals b over 2a, that gives you the x for the vertex, and then when you plug in the answer for that into the equation, it'll give you the y. So like the vertex of the equation is going to be your x for the coordinate, and then that'll be the y for the coordinate. So this is your like coordinate for the vertex. So that's not the x-intercept, I guess. It's just the vertex of it.
Okay. Okay.
So my only idea is to continue with what I was kind of doing
Yeah.
and completing the square that way. What do you guys think?
Yeah, I think that's all right.
Okay.
Yeah.
I'm gonna go step by step to the point where I was at, and then we could see where we go from there. Then you guys can tell me if you guys want to go with that or not. So I'm just gonna write the function y equals. Is it kind of blurry right now?
That's pretty good.
Y equals ax squared plus bx plus c. So in my mind, you subtract the c plus bx. And then, like in my other problem, you divided this coefficient by all of them so that you can get x squared by itself. So then you get x squared plus bx over equals negative c over a. And then you would have to divide this right here by 2 so that you can get like x whatever squared. But to do that, you have to square whatever this. You have to divide this by 2 and then square it to add that to both sides. So if we did bx divided by a, and we divided by 2, it's really just timesing by 1/2, right?
Yeah.
So then if we divide that by 2, it's really bx over 2a, which kind of makes sense because we talked about b over 2a.
Mhm.
And like right now, like what the kind of function we're doing, in my opinion, is kind of like a generic one. So usually we have like whatever if this was 1 x squared plus 2x plus 3, a would equal 1, b would equal 2, c would equal 3. Like if we would plug those into the quadratic formula, right? So that's just a thought I had. Then we would have to square this and then add it to both sides. So it'd be b squared x squared over 4a squared. And that's added to this side. But then you have to add it to this side. So it'd be b squared x squared over 4a squared. So it's kind of got ugly. But this would be plus bx over 2a equals, and then all this shebang over here. And then you would square root both sides, and then subtract the bx over 2a. So you think I'm going in the right direction, or we're not going the right direction on this one?
I feel like we're going pretty close to the right direction. We're getting farther than I was getting.
Yeah. I'm still just confused about finding multiple x-intercepts. Like obviously you have to have different. There's
I
different
think our
solutions
multiple
for it,
x-intercepts will come from the plus or minus. So
Okay,
one
so what you mean.
intercept will be plus and one intercept will be minus.
Yeah.
mean, that's what I got when I did it. I don't know if that's right or if that's
I think
super wrong.
I think we're going right there. I like that.
Yeah, I like that too. It's an answer, and I don't really have one side. I like that one.
Cool.
It makes sense, like where you.
That's a better answer than what I got going.
So we'll do that for number 1.
Yep.
Yeah.
That'll work for number 1, and that'll make let's see. Group quiz B. What is the y-intercept for the given quadratic formula?
Don't for the y-intercept, you just put 0 in for x.
Correct.
Yeah. So it's just
So that
0
would just
C.
make it just y equals c, right?
Yeah.
Yeah, so that's pretty simple.
So we're starting number 2.
Yeah. If you wanted to keep track on your paper, since you got real nice handwriting and keeping everything clean,
I
then
can try.
I can either send you the link and you can be group leader this week, and you just put the link with so you put the link in the group submission link, or if you sent me a picture of your notebook, I could do all the other stuff too and submit the notebook as one as well.
Do you mind if I just send you
Either
a
way
picture?
works. Yeah, you can just do
Because
that.
I
That'll
don't have a
work.
scanner. I don't know how you were gonna do it.
Oh, if you send me a picture, it's already on my laptop, and I can take the picture straight over.
Okay, sounds good. So for number 2, I thought we could just go ahead and start getting the zeros using the rational zero theorem. But I didn't know, because it says like what needs to be done to the function. Like, I mean, they're in order. They're simplified
say
from the
nothing.
coefficients.
Yeah, the coefficients, everything's in order.
Can't we clump like 2x to the 4th minus 5x to the 3rd and find like the ordered pair for that one? Like, can't we do that? No.
Or actually, could we pull an x out? Oh no.
Yeah, we could. Yeah, we could take an x out.
Yeah.
Because that would give us 2x to the 3, x squared plus 6x minus 15. And if we take x out,
So then we could do the roots theorem. Right?
Yep.
So this would be P, this would be Q, and it's P over Q equals. So here's just 15 and 1. Or 5 and 3, 15 and 1. Those, right? Does that make sense?
Yeah.
hold up. Yeah, I got a little lost for a second.
Plus or minus 15, plus or minus 5, plus or
Yeah.
minus 3, plus or minus
So
1.
I'm just looking at the rational zero theorem real quick, and taking out the x was the right step because it's cubed, squared, and then regular x. P over q plus or minus. Yep, you're going the right steps there. Because you're using the first number and the last, right?
Mm-hmm.
Yeah.
So 15 and 2. Oh, this can be a lot of them. Here, I'm going to put this down and do them. I'm going to do them. Are those the ones you guys got?
Yeah. So I just did the one for plus or minus one. I did both the positive one and the negative one, and it doesn't
Mhm.
work. So that can
So we can cross that one out.
yeah, that one can be taken out right away.
Yeah. Do you guys know any faster way than plugging and chugging on all of them in there, one by one?
No, I don't know one.
No.
I don't know one either. Should we split it up and plug one in, a couple each?
Yeah, that actually sounds great.
All right. You want to hold up your notebook there? We can.
Plus or
So
minus
who-
3 doesn't work. It looks like either.
Plus or minus 3?
Yeah.
You want to try 5 next since that one's kind of.
Yep.
Chris, do you want to do the plus or minus 1/2 and plus or minus 3/2?
Yep. I'll do those two.
Oh, okay. You're Chris. Sorry. I missed the
Dakota.
introductions. Dakota,
I'm
Ryan,
Dakota.
Chris.
Yep.
Dakota, do you want to do the first ones on the left?
Yeah, so the plus or minus 15/2 and the plus or
Plus or minus
minus
15.
15, and we just plug that into the regular equation and see if it equals 0, right?
Yep.
Okay.
And Ryan, do you want to do the plus or minus 1/2 and plus or minus 3/2?
Yeah. Okay.
So I guess I'll do plus or minus 5/2. And plus or minus 5.
So plus 15 doesn't work so far.
Plus 5/2 works, though.
All right. Well, since we have 5/2, I'd figure if we just plug that into the equation now, doesn't that give us the rest of it?
That'll give you 1, 0. You have to do each and every one of them to see if they equal 0.
I thought because trying to think of.
Because you could have multiple zeros.
Yeah, but I thought once you found one of them, if you use that.
So none of the plus or minus 15 works, just so we know.
So you said plus or minus 15/2 doesn't work and plus or minus 15 doesn't work?
No, just plus or minus 15. I haven't done the over 2 yet.
Okay. I'm going to do the negative 5/2 and see if that works.
Yeah, so since we have it, if we like pull out, you said 5/2 worked, correct?
Correct.
So if we do like x minus 5 over 2 in like parentheses, and then like pull out 5 over 2 from the rest of the equation, it'll give us the other zeros.
You're gonna have to show us on your paper. At least me.
All right, 1 second.
So plus or minus 5, 15 over 2 doesn't work either.
I don't think negative 5 over 2 worked.
Did we have any that worked so far?
Yeah, just the 5 over 2.
Because the ones that I was doing, either I'm doing them wrong or they're not working. But I'm pretty sure I did it right.
I'm thinking negative 5 over 2 works. Because so far, mine are working. Well, at least it looks
Nick-
like it. We'll see. I don't think it does, the negative 5 over 2, because I get negative 92 and a half.
There's something wrong. I didn't get negative 92 and a half when I did it. I probably did it wrong, but I didn't get 0. So if we both got something that wasn't 0, that's probably not the right answer.
Yeah. I thought I was going to get 0 because the 2 by negative 5.5 cubed, I got negative 31.25.
Mm-hmm.
And then the 5 to the 5 over 2 squared, I got 31 and 2.5. But it's a negative minus a positive. So I'm pretty sure. No.
Yeah, I did 5 over 2 again just to make sure I didn't do that wrong, and that did give me 0. So right now just 5 over 2 works.
Yeah, I think that's all we got so far.
Yeah, none of mine worked.
And then Ryan said that his didn't work.
I got through the plus and minus 1 over 2, and neither of those worked. I'm still working out the 3 over 2.
Uh, 3 over 2 didn't work. And negative 3 over 2 got me 63, so that probably doesn't work.
Yeah.
Well, we know 5 over 2 works. And because of what was the other thing we had to study this week? It was called the zero product theorem. Because since we pulled out an x in all of them, for sure 0 is an answer. Because 0, if we put 0 as x when we pulled out the x times everything else, it's going to equal 0. So we know for sure it's 5 over 2. 0 is another answer. And if we can't think of any, if none other options work, then that's it.
Yep, I'm thinking so. Yeah, 5 over 2 definitely works. I got that. 0. No problem. So yeah.
So for A, it was factor out a 0. Factor out an x.
Yeah.
Yeah, A was just factor out an x and then find all real and imaginary zeros for the function. That's just 5 over 2 and 0. But does 0 work? Because once we factor out an x, everything goes away except for the negative 15.
No, once we factor out the x, if we put 0 here at this x, 0 times negative 15 is still 0.
Yeah. Okay, yeah. Yep, we're good. I got you now.
So how should I word that? X equals 5 over 2 comma 0?
Yeah.
Sure.
Uh-oh. Yeah, there you go. I'm going to rewrite that. So we all agree on that one?
Yep.
Yeah, I think that's great.
So number 3. Explain a difference if there is one between x-intercepts, roots, zeros, and factors. If you use definitions, examples, you may use definition, examples, graphs in your explanation. So my opinion, I thought they're all the same. Because your x-intercept is where your function crosses the x-axis. Your root is where, again, it crosses the x-axis. Zeros are your zeros, obviously. I feel like I'm using the same words, but I didn't see any difference. When I've seen different videos, they all called it different things too. Like they said, oh, we're going to find the root, or we're going to find the 0, or the x-intercept, or the factors. They're all the same.
Yeah, and I feel like you can use the other words in the definition of the one word. So like the x-intercept is pretty much where the zeros are, and then like the zeros are where the x-intercepts are. So like it pretty much is the same thing because you can use each word in an alternate definition.
Yeah, and then I just looked up the definition of roots in math, and that's a real number x will be called a solution or root if it satisfies the equation, which is just a 0 pretty much.
Yeah.
The roots are exactly the x-intercepts of the quadratic function.
So our answer is there is no difference between x-intercepts, roots, zeros, and factors.
Yep.
Yeah. Well, what about factor?
Factors.
Factors. Hold
'Cause
up.
are we allowed to use the? Yeah, I'll ask later.
See, I don't know if that's right. This is just what my computer says is the definition of factors in mathematics. A number or algebraic expression by which another is exactly divisible. So, like the factors of 15 are like 3 and 5 and 1 and 15, you know?
Mm-hmm.
Is that lining up with our definition of x-intercepts? Because intercepts, roots, and zeros are all the same.
Oh, but like with the quadratic function, if you factor it out, you get your x-intercept.
You get your x-intercepts. Yep, there you go. Yeah. Yeah, so they are the same then.
So you guys good with just
Okay.
this?
Yeah, I mean that's
Yep.
pretty much.
That's basically what we did, yeah.
All right, sounds good. I guess we're done now.
Alrighty,
Unless one of you guys
guys.
wait, just a quick question. Did any of you guys do the extension problem number 2?
In the preparation.
Yeah. It was the only one I didn't really understand how to do. But the word problems always kind of
So with this
Get
one,
me.
you have to find the vertex. So that equation that I was telling you, where it's
b over 2a.
b over 2a. Yeah, I'm pretty sure because on the homework I didn't do a problem like that. And so you find the vertex, and then it'll give you the height.
Mhm.
And then once you have the height, then I think that's it. And then you just like make a graph for it. I think.
Okay. Well, I haven't started any of the homework, so I really need to start on that so that
Yeah,
I can do
but
this stuff.
with the homework, like I was saying, like it'll be in the top right corner. It'll say like something like help, and then it'll show you an example of it. And so I use that a lot, like during the homework.
Yeah.
I was confused on something, and I'm pretty sure that's what it told me to do for the problem similar to this.
Okay. I'll just end up doing that. So we good?
Yep.
Everyone?
I think so.
Yep.
Everybody good? Alrighty. See everybody on Tuesday. Have a good weekend.
There you go.
See ya.
Bye.